And let's begin the class about fluid mechanics. So in this, we're gonna study a bunch of things, and you guys can recall whatever you have studied in BTech also. So tell me first thing, what is fluid when you compare it with the liquid? Any guess? What does this one letter makes difference? Fluids versus liquids. Any answers, please?
I think fluids are incompressible.
Fluids are incompressible. Mm, no. Any other answers?
Oh, all fluids are liquids, but not all liquids are fluids, something like that.
Yeah, you're almost near. You are almost near. So you have missed some other form of objects. There are three forms of objects, right? What are three forms? If you take a water, it has three forms. What are those three forms?
Liquid, gas, and paper.
Yeah, okay. You're saying yes, vapor, this is water, and this is ice. These are three forms of water, especially. So when you say it in physics, the first form is solids, liquids, and what is the third thing?
Yes.
Yeah, gases, gas. So the liquids and gases together, we call them as fluids. And in this subject, we're gonna study about the fluids. That's why we have fluid mechanics, which means that we not only study only liquids, but we also study about gases. But to be very frank, for FE syllabus, predominantly we're gonna study about the liquids. And coming to the gases, we study about, the gases are there in our air, that is atmosphere. That's why we study a bit about atmospheric pressure. Yeah, this is about the three forms of an object. And what is fluid is? Fluid is nothing but the combination of liquids and gases. Both are called fluids. So some of you have said that all liquids are fluids, but all fluids are not liquids because there are gases also. Some fluids can be gases. So that's the thing. Let me go further. So tell me, guys, give some examples of fluids in your day-to-day life. Let me know. Proceed.
Water,
Okay. Water or should roll, not water. Next, proceed.
Oil,
Yes, please. Oil. Yeah. There are plenty of oils. Any one oil, please? Kerosene.
petrol.
Yeah,
Yeah,
petrol is one of the fluid or liquid. Anything else?
milk,
Yes, please. Leak. I did
milk,
not get you. Milk. Yes, perfect answer. This is a
air,
liquid. Air. Yeah, air can be also a fluid. Proceed. Then,
Mercury,
perfect. Mercury is also a fluid, which is a very famous liquid that has been using in fluid mechanics, especially you can see in thermometer, in manometer. In most of the things, they use mercury. Why they use
honey,
mercury? S plus?
because of its melting point.
Yes, you're almost right. Because of this melting point, this is one of the reason, and there is one more reason left. Guess.
Heating point.
One more thing is, you can guess it.
Heating point,
Not heating point and melting point are almost same.
lighter than water,
Yes, please.
lighter than water,
Uh, I'm sorry. Dash than water. Something I couldn't hear this properly.
lighter than water.
Tighter than
Lighter.
water.
No, it's not lighter. Do you think it's
Heavier,
lighter? Yeah, it's heavier than water, right? That's
I don't know what.
Yeah, it's heavier than water. It's heavier than most of the fluids actually. That's why they use mercury.
High
And
High
what?
density.
density.
Yeah, the heavier than water itself, it indirectly says that it is having high density. That is the reason why we use mercury. And why high density is needed in flow measuring devices or so on. So I will let you know when you go into the subject slowly. Okay, so you guys have given plenty of fluids examples: water, kerosene, petrol, milk, air, mercury. Anything else you missed?
Honey.
Is shampoo included?
Which one?
Shampoo?
Shampoo, yes,
Um,
it is also a kind of a fluid. That's a right answer. Yes,
honey.
perfect, perfect. That's a very good answer. Honey is also a fluid. Then
Sand?
sink.
Sand?
Sand. Sand cannot be fluid. Is sand a solid or a liquid or gas?
Solid?
Yes,
Like in
sand.
sand, there is one more, like, I'm not getting the name. The quicksand?
Yes, you're saying the quicksand. Okay, you can take it. Actually, quicksand is not a sand, it is a phenomena that takes place in
Yes, yes.
yes, geotechnical engineering, where there will be, the change of pressures, etc. Anyway, but we can take. Yes, please.
Crude oil.
Yeah, wine.
Gases. Gases like oxygen, hydrogen, carbon
Yeah,
dioxide.
yeah, all the gases, oxygen, hydrogen, carbon dioxide, etc. They are also
Does it
fluids.
include
Hmm.
like tea and coffee?
Yeah, tea, coffee, cocktail, anything, everything. Vodka, everything comes under liquids and gases. So you guys now got a clarity what are liquids and gases, what are not solids. Let us go further. This class is an introductory class. First, we need to get our emotion out towards the fluids. Okay. If I take water and I'll take a plank, this is my kitchen. This is a kitchen, what I can say, kitchen floor. And over this, I have taken some board, chopping board. Over this, I will drop a single drop of water and I will take the honey I will place it just adjacent to it. This is one drop of honey. You guys tell me, out of these two drops, which drop will reach this bottom first? Who wins the race? A drop of water versus drop of honey.
Water.
Water.
Okay.
Water.
Someone said
Honey?
honey. No. How does honey comes? I think you bought fake honey. You should buy from someone else.
Yeah,
Okay.
but honey has more weight to it, more pulling capacity,
Okay. Your
which the
perspective
gravity
is
will
right.
affect.
I understand your perspective. But practically, if you try it in the kitchen, obviously the water comes first. You are now in, mechanics of materials and statics. You should jump to fluids. In that perspective, you can see honey comes later than water. You guys tell me what could be the reason?
Dense. Viscosity.
Fluidity.
Mm,
Low
yes.
viscosity.
Yes, someone said the right fluid mechanical term, that is, there is
Fluidity.
some term called viscosity. Some materials have, a very free nature to move among itself, like water has.
Oil.
Yes, please.
Oil's viscosity.
Yes, oils have more viscosity compared to water, and honey has more viscosity. That's why the relative motion of this fluid will be lesser. So this is one term. Lamely, we can listen one term. This is viscosity. Okay, we'll study about this in tomorrow's class. And tell me, and you guys already said, if I take, a glass jar, and I will ask you one practical question. In this jar, I pour two things. With 1 cup, I pour, what can say, let me take another color. I pour water. So water is poured from here, and I will take one more beaker, and I will take in this kerosene, and I will pour kerosene in this here. After that, there will be 2 layers formed. So you guys tell me, this is the bottom layer, and this is top layer. In the bottom layer, what will be the fluid? On the top layer, what could be the fluid?
Kerosene will be on the
Bottom
top,
water.
water will be in the
Bottom is
Bottom.
water, top is kerosene.
Kerosene on top, water and bottom.
Yes, you guys are right. Kerosene at top and water at bottom. So what could be the phenomena, the fluid mechanical property, which is causing them to stay like this? What is the difference? What is that phenomena?
Water
kerosene
has
is less dense
low
than water.
density.
Yes, you guys are right. The second term is density. So one of the second fluid property is density. We'll study about this density tomorrow again. This density has different forms. Can you guys try to recall their forms if you know? If density is denoted by the symbol rho, which is mass by volume,
Volume.
it has some other form. If at all, if I take instead of mass, that is weight by volume, this has some other name in fluid mechanics. This name is something. Can you guys guess?
Specific gravity.
Yes, you're almost 50% right. It is not specific gravity, it is specific weight. The weight per unit volume, which is denoted by the word specific, is specific weight. So one is
So
density. Yes,
rho
please
g
proceed.
is with gravity, and then what is rho? I mean, what is specific weight of a vehicle?
Yeah, rho is the symbol for density. Now you have recalled your brain. This is nothing but rho into g, because you guys know weight is mass into gravity. So when I take mass by volume, that is rho. This is rho into g, and the symbol here is gamma. Specific weight is given by the symbol gamma, which is like this. Gamma is rho into g. We'll study about it tomorrow with the units, so and so. And
But
yes,
I have a
mm,
quick question. But in
mm.
soil mechanics, we use gamma even for mass by volume formula.
No, you might have no. Are you sure?
Not sure. Like,
What about
not sure, but yeah.
what about the other guys? Did you guys notice that they're in mass by volume taken as gamma?
It's mu, I believe.
Yeah, it might be different, I'm sure, because even in soil mechanics, the same fundus applies. There you guys will be having gamma, and gamma will be of different types in soil, that is gamma saturated, gamma solid, gamma bulk, so and so.
Gamma
Uh,
submerged. Yeah.
yes, gamma submerged, etc. There it is gamma only. If at all we have taken rho, we have to take the units kg per m cube, and if it is gamma, it will be in kilonewton per m cube, or kips or ksi,
Yeah.
so on.
Yeah.
Yeah.
Yeah. So I was wrong.
Yes. Okay, that's good. Then proceed further. The second fluid parameter, that is density. When you denote this density, if I take the density of a kerosene by density of water, we call this as something someone said before. This ratio, we call it as specific gravity. Or sometimes we can say it as relative density also, since we are comparing two densities. So yes, this is all about the second parameter, fluid parameter, that is density. Now, let me come to the third parameter. I will ask you. You guys might have seen. Let me take a pond, something like pond. When it see it from the top, it is a pond. And let me take a marker, go to the largest size and fill this pond with some water from the top. And yes, you guys might have noticed on a pond in your childhood, there might be some insects, something like this, that are floating on pond. Did you guys notice those insects?
Yes, the specific gravity is looking at that way.
It's not specific gravity perfectly. There is some other phenomena.
Weight.
Right. I'll show you one more thing. Water. Swimmer.
I think there is this
Hmm.
phenomena which goes
Hmm.
with weight and spread of the area. I don't recall the right word for it.
Yeah, you're almost near.
Surface tension.
Yes.
Leon's.
I don't want to type the actual phenomena here. That's why, yes, this you can see here. This is a famous, one of the achievement for the photographers while the swimming competitions are going. You can see
Surface tension.
this. Yes, this guy is swimming in water, and when he tries to comes to the surface, and when he proceeds, at first nanoseconds, the water will not break. It will take the form of the body of the swimmer. Why the water is taking this form? We could have break the surface and it could have remained flat itself. Why it is not flat? Because the water has the negligible, very slight amount of tensile strength at its surface. So the tensile strength at the surface of the water is known as surface tension. So this is a phenomenon you can notice here. It's at stretched like a balloon, like a membrane. The water has taken the form of the swimmer. So this is a third phenomena. I hope it is clear by now. The third fluid parameter is surface tension. This is one of the phenomena you have seen. Tell me what are the other places where you can see that water or some liquid existing, showing its surface tension. Can you name them? Some other examples where you can feel the surface tension of the fluids, especially water.
Oil.
Bubbles.
Yes, perfect. When you blow the bubble, it takes the form of a
Layman-Frost
bell.
effect.
Yes, please.
Layman-Frost effect when you pour water over a hot pan.
Like your voice, I could not understand the words. Can you say it again?
I think there is this phenomena called Layman-Frost effect where you pour water on top of a hot pan and then water does not burn.
Okay. Acha. Lenin-Frost effect. This word is not clear for me. Your words are slightly cloudy. Okay. Yeah.
Raindrops on glass.
Raindrops on glass. Raindrops themselves are the reason for surface tension. Why the bubble takes spherical shape? Why not? You could have got the doubt. Why not? It could have taken the cuboid shape, or why not? Something like semi-spherical or some irregular shape. Why it is especially taking the pure spherical shape when you blow a bubble? Why it is taking the spherical shape? The reason is actually the surface tension. Any guess why the surface tension is causing the bubble to be spherical?
So to put pressure on all sides equal.
Yes, exactly.
Contact area.
Yes, you guys are right. The first one who said is right. You do one thing, go to your ground. 20 people, 20 friends of you go to your ground like this, and this is your head and hand, head and hand, head and hands. And join your hands together like this. when you join together through your hands and try to pull the maximum effect with your hands, then your shape will form a circle, right? When you try to pull your hands from each other, it will form a circle. The same phenomena here, the each atom of a water, when it try to exert the surface tension phenomena on each other, since everyone are human beings, or every particle is atom, they will be having same tension. That's why it will form the circular shape or spherical shape. That is the reason we need not to go such deep for a FE exam. And anyway, what is the shape of raindrop? Is it spherical or something? Is it like this? Case 1 and case 2.
The teardrop, because there is only pressure from one side.
Now I'm
Okay.
asking the shape of raindrop that is falling from cloud to the earth, is it 1 or 2?
2.
2.
Okay, that is 2. I agree. Similarly, why, even though there is surface tension, why the shape is like this rather than this? As per the phenomena, it should be like this, but here
Air is
happening.
acting only on one side.
Gravity.
Due to
Yes,
gravity.
yes, because of gravity, the shape slightly gets deformed. Suppose if you are in a ship, international, space ship, there you can see the astronauts blowing through their mouth water. It will be forming a sphere rather than the airdrop, because there is no gravity. Then the surface tension acts. It will be again purely spherical. So this is all about the third fluid phenomena, that is surface tension. Okay, now tell me guys, what are the other things you recall about the fluid properties? Any guess? Yes, if you talk about water, you have given plenty of examples like water, kerosene, so and so. What could be the other parameters? We have studied till now the 3 parameters, that is density and the different forms, viscosity, which is like the freeness to move, and then surface tension. Proceed further. What are the things we can
Temperature.
Yes, the fluids have temperature. I agree.
Pressure.
Perfect. That's a very good answer. Pressure. Fluids have pressure. Can you give some practical examples of pressure?
Water coming from a faucet, from a tap.
Water tap.
Okay, water coming from a tap. Okay. Yes. Let me take. You guys are almost right, but technically speaking, it is
Hydraulic
not.
jugs.
Yes, that's the right answer. I admire your answer. Hydraulic jugs. This is a phenomenon where you use the pressure parameter, the pressure quality of the fluids, and we used to lift heavier materials with minimum efforts. So how does it do? Again, there is some Bernoulli's principle. The pressure should be same at the same locations, Pascal's law. So P1 A1 is equals to P2 A2, so and so. I will tell you what that application is. Hydraulic jugs is one of the best example for pressures. Okay, since you guys said the tap, let me come to the your assumption. Suppose this is a multi-story building with the doors and windows, doors and windows, doors and windows, doors and windows, and here is the water tank with some water filled in this. This is some water here. This is the top layer of the water. And now we did. Okay, one question here. I don't know. In US, do you guys follow the system of overhead tanks like in India? Is it there?
No.
No, it's just water from the water main line. That's it. I think it has
Okay.
the pressure, so it reaches
Mhm.
the faucet.
So,
To maintain
okay.
pressure, we got tanks in the area, but not exactly on
Acha.
individual house.
Okay, so you guys are saying that if it is my ground surface, you are getting the water through pipes from the ground, through the pipes. Okay, I understood that. And again, through the pipes, the water can come only because of 2 reasons. One is the gravity, the pressure due to gravity or pressure due to external resources. So some of you guys are saying that there are some tanks, overhead tanks that are very taller than the households, and then from this water you are getting water. Is it so or something else again?
Yes, that is right.
Yeah.
Individual areas have their own time.
Yeah.
Chain.
Due to head difference.
Mm-hmm. Yes, you are into the subject. You are right. There are two possibilities. One possibility is they have to construct the tanks at, obviously the level of this tank, the top layer should be above the level of that so and so community, so that because of head difference, there will be flow of water in this pipe. And why there should be head difference is, it's not primarily head difference, there should be energy difference. Total energy here should be greater than total energy here. Then there is some natural phenomena, that is energy flows from higher energy to lower energy to keep the things balanced in the nature. So that's why, and under that phenomena, that is Bernoulli's principle, the water will come from here to here so that you'll get water. And some other possibility is, suppose in some locations where there is no tanks, there can be the water treatment plant at lower level itself. This is a water treatment plant where they collect the water from natural resources, and they convert it into usable water, potable water, and then they use some pumps here, highly energized pumps using some electricity. They use these pumps, they will give some energy to this water, and because of this higher energy, even though they are at lower level, their energy will be greater than energy here. That's why water will flow from here to here. So I can say the one of the other fluid parameter is energy. Under this energy, there are different types of energy for fluids or liquids. If you take the water, there are practically three types of energies. You guys tell me, what are the three types of energies? Any guess?
Kinetic energy.
Yes. For a water that is flowing, there will be kinetic energy.
Potential energy.
Yes, potential energy.
Thermal energy.
Static energy.
Static.
To be precise, we have pressure energy, because static itself is pressure energy. Got it? So there are three basic energies: kinetic energy, potential energy, and pressure energy. Summation of all this, we call it as total energy. And based on this total energy, we can decide from where the water flows from A to B or B to C based on this summation of energies. Okay, so we're gonna study about the density, viscosity, surface tension, temperature. We don't have much syllabus for FE. Pressure, energy. Think of any other parameter. Anything we missed? Any guess?
Buoyancy.
Compressibility.
Yes. Okay. Yes, that's the right answer. Compressibility. There are some fluids which can be compressed, and there are some fluids which cannot be compressed. Suppose, especially when you take the gases, when you take, the are you guys using what is a gas that you guys are using in gas station? Can you guess?
Gasoline.
Gasoline.
Ethane.
Okay. Yes.
Ethane.
To
Ethanol.
yes, it's a ethane or ethane forms, that is ethanol, etc. So these gases, when it is poured into your, the tires of your vehicles, they will be entered into your tire under huge compressive forces after compressing them under lot of pressure. So which we call them as compressibility. When you take the water is the material which is almost having zero compressibility. You cannot compress water. You can compress gases, some of the gases. And the compressibility varies from gas to gas. It can be more from some gas, it can be less from some other gas. So this is other parameter, but anyway, it is not there for our FE syllabus. We almost covered all the basic fluid properties. Let me think. Did I miss anything else without seeing the notes?
Do we have buoyancy thing?
Specific gravity.
Yes, specific gravity, as I said, it's a sub-parameter of what? Out of all these 6 parameters,
Relative.
specific gravity is the parameter of density actually, right? Someone said buoyancy. Okay, there is something called buoyancy. You are right. I agree with that. It is one of the parameter. Let me take that 8th parameter as
Doesn't
buoyancy.
it come under surface tension?
No, buoyancy doesn't come under surface tension, but it can come under something else, some other parameter out of all these 7 parameters which I've done. Any guess? You're almost near since you're thinking.
Vapor pressure.
Buoyancy. Okay, you guys, this is a
Pressure
some other
energy.
parameter. Vapor pressure.
Compressibility?
No, it doesn't come under compressibility also.
Pressure
Okay.
energy.
Not even pressure. Yeah, it is somewhere related to pressure, but not pressure energy. So let's have quick look what is buoyancy in your day-to-day life. Tell me, what is buoyancy?
Like the swimmer getting out of the water. When the wood is put into the water, it's coming out.
Okay, that is right answer. That is one of the best example. Anything else?
Balloon.
Like air
Like,
bubbles in the water rise upward when falling down.
Yes, that is also buoyancy. I agree.
like
So what's
equal volume getting replaced.
Yes, that's a very technical answer. That's right. I agree. But
Mhm.
why the all the examples you are saying they're coming up? What is the thing there? What is the magic there in
Density.
mhm.
Dense.
Is it
Anything
density?
denser than water.
Okay, I agree.
Displacement of water.
Yes, displacement what with water is the action that is happening. I am asking, you are right, your answer is right. There is water being displaced in the buoyancy. But why the water is being displaced? Why it is happening?
Because of two
Someone's
different densities.
okay, you are right. Because of 2 different densities, and density is actually related to pressure actually, because of 2 different pressures. So there the answer lies. It is not the actual class. Remember, I'm just giving the summary. Let us take a big swimming pool. This is my okay, not an issue. It is a pond. Let me take a pond, and it is a top surface of the pond, and the pond is filled with water like this. And this is the pond. Okay. Now, when I take a small object here, suppose if you are playing in a swimming pool, a bunch of guys are playing, and this is the ball, whether it is a basketball or football. When you try to place this ball here, the water will not allow this ball. No, I will not allow this ball. I will just throw it out. So the ball will quickly rise to the top surface. Even if you guys want to see the magic here, if you try to pull it down with some, pressure and release it, even it can jump out of the surface and fall back here. That happens. Anyway, we'll see that later.
But
Why
then
it's happening?
isn't specific buoyancy related to individual materials, not exactly liquid, but it could be solid as well. I mean,
Okay.
since we are looking at
Okay.
ball, this is air in it.
Yes. Your answer is right. The buoyancy depends on the liquid that is displacing the object as well as the volume of that object, but not the material of the object. Clear? Whether it is a ball of so and so shape, or it is a ball made of wood, or ball made of I can say ball made of steel also, the buoyancy acting on the ball will be same. But whether the ball to come up or not depends on the material of the object. What I'm saying is this buoyancy will be exerted by the fluid. Suppose I replace it by the letter buoyant force. The buoyant force exerted by the water is actually weight of the fluid, the same fluid which is extracting the buoyant force, displaced by the object. By this wording, can you guys say that it depends on whether the ball is wood or steel or so on so? Do you guys think that? I'm going
Yes.
into the subject. So the buoyant force is nothing but the weight of fluid displaced by the object. So the fluid will be displacing only this amount of object, right? The object will displace this amount of fluid. So whatever the fluid weight in this ball is, suppose I am to say, suppose volume of ball is 220 centicubic. So the volume of water that will be displaced is 20 cubic, and the buoyancy is weight of water of 20 cubic. So that's why I'm not going to deep. The buoyancy depends on the shape of the body, the volume of the body, but not the material. If the buoyancy is same, then some materials will come to the surface, some materials will not come to the surface, because it is a net effect of two phenomena, that is a buoyant force and then the weight. Suppose if the buoyant force is very high compared to the weight, then only this ball will comes here. When I take a steel ball, there will be same buoyant force, but comparatively the weight of the steel ball will be very high. That's why even though buoyant force will be acting, this will fall to the bottom rather than coming up. It's a comparative game of buoyant force versus the weight of the body. That's the case. Even when you are going, I will give one more examples of this buoyancy. This is a swimming pool, and this is a surface, and there is a weighing machine over the surface. I hope you guys are listening to me. I place a weighing machine here, and I'll make your friend to stand over there. On this weighing machine, suppose it shows you 100 pounds is a weight. If the same guy, if this is my water over here, and I place this weighing machine here, somewhere here, and I'll ask him to take the weight in this water, inside the water. Can you guys guess what could be the weight shown here? Will it be 100 pounds, or it will be greater than 100 pounds, or it will be less than 100 pounds?
Less.
Less.
Yes. Why it is less? Because when he is inside the water, his weight will be acting like this, which will be same, but there will be some more opposing effect, that is buoyant force acting here. Because of this, on this mission, the net effect will be W minus FB. Because of that, it will show something like 90 lb, so and so. So this is other parameter regarding the buoyancy. And yes, now this is a thing how the subject looks like. Let me jump into syllabus. Teachings, coming to the fluid mechanics. Yes, this is my notes made by me. The fluid mechanics has so and so things, and this has around 6 to 9 marks. Out of this, the handbook, when you see the handbook, the latest version, there will be lots of things, around 12 topics are there. As I said, the topics in the handbook are common for chemical engineers, mechanical engineers, and civil engineers, so on so. But for our civil engineer, we have only these topics like flow measurement, fluid properties, fluid statics, energy, impulse, and momentum. What is this energy? We have seen that is there will be total energy combination of potential, kinetic, and pressure energies. Impulse is nothing but, you guys know, when you if you take a dam, they are storing the water in reservoir. When the water level is very high, they release this water. I'll show you one phenomena here. This is one dam here. This is dam like this. And there is a catchment area, which is nothing but reservoir. And in this reservoir, there will be, the water stored due to rainfall. And at the downstream side of the reservoir, there will be what are these called? What are these things called? Any guess?
Turbines.
So there will be turbines here. And these turbines will be connected to energy generators, electricity energy. What we call this generators, electrical term, I don't know whether it is DG or something. Anyway, so when the water level here rises and rises and rises, so this water, which is not moving inside the reservoir, what energy will we be having out of three forms of energy? You guys tell me.
Potential energy.
Yes, this will be having potential energy. Then what we do, there will be gates opposing this water to flow. So when the time comes, they will lift these gates. The gates will be lifted like this. So they will lift these gates. Anyway, I think they're coming. Yeah, they will lift it like this. So this water will flow like this through the gates. Sorry. Anyway. The water will flow something like this, and they fall from very high, and they will try to hit this vanes of turbine here. So this hitting force on vanes, we call this impulse force. You can notice the potential energy is converted to kinetic energy, and the kinetic energy is causing some impulse force. Because of this impulse, the turbines will rotate. Because of that, we are generating mechanical energy, and the rotating turbines will be connected to axis. This axis will again, related to electromagnetism. There they will generate electricity. So this is how the energy will be transferred from one form to another form in generating the energy and storing them for our day-to-day life. So this is about the impulse. Impulse is nothing but the impact, the water jet that is hitting a surface and making it to move so that the mechanical energy is generated. That is impulse. And momentum is also again another form of, the fluid in motion, where momentum, you guys know, this is a mass into velocity is a momentum. With there, we have some phenomena. We'll see about them. So coming to the fluid flow measurements. Okay, let's see this. When there is flow happening inside a pipe, we can measure what is the flow that is happening. And for that, we missed one more parameter, that is the parameters related to flowing. So can you guys guess what are the different parameters related to flowing? That is, it will be having some velocity, right?
Velocity and
Yes.
viscosity.
Yeah, viscosity, it will be there. Obviously, we have studied. And what is one more parameter that is related to velocity? Velocity into area is called something. What is that called?
Discharge.
Yes, it is discharge.
Discharge, okay.
Yes, we call it as flow discharge, or we can call it as volumetric rate of flow. There are different names, but by the name itself, you can understand. The rate of flow, that is flow for unit time, is known as discharge, where the discharge will be having units like meter cube per second, or cubic feet per second, so on. So this is a discharge. Actually, the discharge can be in other form, that is mass flow rate, which can be in kg per seconds, they will say like, if it is my big pipe flowing like this is my pipe cross section, and this is a fluid flow through this pipe. The fluid will be going like a, vehicles in the traffic in the road. You can think like them as cars and lorries, so and so, trucks. So this is a fluid particles flowing. Each particle will be having different velocities. This car might be going with higher velocity V1, this one might be going lower velocity V2. Different brands, different cars will be having different speed, mileages, etc. So these are different possible velocities. Similarly, when I talk about the discharge, we talk it about a section. At a section, what is the traffic at a particular area in a city? We can say that here the traffic is very fast. I mean to say, there are 20 number of vehicles are crossing this area per second. This we call it as discharge. I mean to say that 20 m cube of liquid has passed this zone
A by
in
V.
1 second. Yes. So discharge is denoted by the symbol Q, which is not A by
Equal
V.
to
This
by.
is A into V, not A by V.
A into
Yeah.
V. Okay.
Yes. So we'll study about this discharge. Now, in a pipe, if someone wants to know what is the velocity or what is the discharge that is, happening in a pipe, you will need not to cut this pipe and take a time machine, take a timer, stopwatch and measure the flow. We can't do that. There are some flow measuring devices which can be used to find the, discharge. Those flow measuring devices are, example, I can say manometer. Manometer is one of the device that looks like it is a U-tube. They will connect from one point to another point. So we call it as U-tube manometer. This can be used to measure the flow. That is the one thing. Actually, U-tube manometer is used to find the pressure difference. With the pressure difference, they will indirectly calculate the discharge. We can see
But
that.
isn't it Venturi meter? The pressure difference?
Yes, you are almost right. There is other device that is Venturi meter.
Capital Q by capital
The
V by is
the
equal to.
Venturi, yes, you're recalling the things that is pretty good. The Venturi meter, what we do, we'll cut these pipes at two spots and remove this pipe and replace this pipe by Venturi meter. Venturi meter again, it's like a pipe itself, but it has some other shapes like this. It will be having a head, it will be having some throat, etc. The water is made to pass through this, and here again we connect the U-tube manometer again to the Venturi meter to know, the pressure difference there. So manometer, Venturi meter, and to measure the pressure, you guys might have heard this word. To measure the pressure at some location, that is especially atmospheric pressure, we have some instruments. Can you guys guess? Pressure is a fluid parameter which we have agreed. To measure this pressure for an atmosphere, we have an instrument called something. What is that
Tachometer.
something? Yes, please.
Tachometer.
Tachometer. Is it used to measure the wind speed, I guess? No?
Oh, yeah, wind speed. That is wind speed.
Something with mercury.
Manometer. Manometer.
You guys are almost near. It is barometer. Yeah, you're right. This is
Barometer.
called Torricelli barometer because this guy has invented this. Yeah, this is barometer. Wow, how does it look like? Someone of you said that. It looks like a beaker and then an inverted jar, and there will be mercury placed here and there will be mercury here. The atmosphere here will exert some pressure. Because of this pressure, this will rise to some level. We'll see this height by which it has risen. Based on that height, we'll do some modifications, calculations from factors, and we'll say, yes, the pressure at so and so location is so and so dash. Can you guys guess what are the units for pressure? You guys already know what are the units for pressures are. Tell me.
Yes, KPI. Atmosphere.
Yes, actually, when I come to
Pascals.
statics or mechanics, we have pressure is nothing but force by area, that is Newton per meter square, or you guys are right, kilopounds per inch square, that is KSI, so on. So, but coming to fluid mechanics, we use
Bar.
this. Along this, we use atmospheres. This is one of the unit, and you are right, bars. This is another unit, and pascals. These are the most, convenient or situational units which we can use in fluid mechanics for pressure. Especially when you talk about atmospheric pressure, it will be in terms of atmospheres or bars or even pascals. We'll learn how to convert from one unit to another unit in the actual session. So from tomorrow's session, we'll study only these things: buoyancy, density. In the first class, we'll study especially about density, viscosity, and there is some other phenomena. Yes, I recalled it now. What is that phenomena? When there is a tree, suppose it is a tree. This is a tree having branches. I want answer from ladies. I request you to answer it. There is a tree and it is a earth, that is a ground. Because of the when you water this tree, it will be having different roots. These are the roots of the tree. Tell me one thing first. The tree and the leaves of the tree, these are the different leaves. Are they taking water directly from the rain, or they're taking from the earth? The leaves are taking photosynthesis. They do photosynthesis to generate, oxygen by taking the carbon dioxide. For that photosynthesis, they want water. So they take water from, my question is it from atmosphere or is it from ground? Yes, I hope there are
Ground.
ladies here. Madams, please, you have to be active.
From ground.
Yeah, from ground, the water will travel like this from through the tree fibers. Tree has microfibers. Through that, the water will come from ground to the stem, to the branches, and then to the leaves. So no pump here to pump this water from ground to the leaves. No one is helping it artificially. Naturally, it is going from earth to leaves. So what is this phenomena of the water which is happening so that the water is going up? Any guess?
Absorption.
Due to
Almost
water.
near. Due to?
Poor water pressure.
No. Pore water pressure is not.
Capillarity.
Yes. That's the right answer. It is capillarity. It's again a phenomena of fluid because of which the water is
Even
coming
this
up.
even
Yes.
this thing is applied in geotechnical soil mechanics.
Yes, exactly. You are right. Which we call it as capillary pressure, right?
Pressure. Yeah.
Actually, this capillarity, why the water is having capillarity? What is the reason? Any guess again?
Head loss.
Not head loss, some other reason. Guess it, guess it. You guys are almost near. I'll tell you. Capillarity is again related to surface
Pressure.
tension. Surface tension.
Like
Why?
from one
Yes.
molecule to another molecule attraction,
Yes.
with respect to geotechnical engineering.
Yes, you're right, actually. That is right. He is saying that if I take a beaker, and okay, the beaker looks like this with the, water here. When I talk in terms of fluid mechanics, if this beaker is very, very small beaker, it has some engineering consideration that its radius should be less than 10 mm, so 10 nanometer, etc. What happens here? The water, you can see the water is here, but water has something called that adhesion, cohesion. Because of this, there will be slightly angle of contact here between the glass. Yes, between the glass and water, there will be some adhesion. Because of that adhesion and because of that angle of contact is nothing but if I draw, some angle like this, and this is a glass, this we call it as angle of contact. There will be a tension developed here because of the surface tension of the water, and this is a T, that is surface tension. Because of that T, there will be component developed in this. This is T cos theta, and because of the T cos theta, there will be upward force. Because of this upward force, there will be a rise in the water. Because this rise is known as, we call it as capillary rise. From here to here, we call it as capillary rise. Similarly, our friend said in geotechnical engineering, when there is earth here, this is the earth, and earth has soil. Soil is nothing but group of particles, isn't it? These are solids. Soil has solids, liquids, and empty space. When you notice microscopically, there will be naturally small voids forming, which will act like glass tubes again. They will be acting like tubes. These are like tubes. Different types of microtubes will be naturally occurred, and there will be water inside this soil because of the rains. So what happens, because of if the tubes are naturally lesser, the water will try to come up, which we call it as capillary rise of water. Because of that capillary rise of water, I have practically noticed in my site, we construct the plinth beams. Plinth beams are generally constructed right above the ground. So because of that capillary pressure exerted by the water in the soil, this beam has bent like this, and there are cracks formed here because of tension being on this side. So generally, when we design the plinth beam, we have to give the tensile reinforcement in the top surface also, at least the minimum reinforcement, so that we can avoid the capillary pressure that is exerted from the ground. Even when you take the grade slab, what is grade slab in structural, civil engineering? Grade slab is nothing but the slab on which the floor lies, right? On the earth, we'll pour a grade slab. There also, rather than, okay, the session is over. I'm just giving you one practical example. When you notice the grade slab, if you guys work at site, in the grade slab, the tensile reinforcement are not given at the bottom, they are given at the center. Why? Because even though the loads come from top, makes it to bend like this, and tension will be at the bottom, but we don't give it like this because this thing is resting on the ground. The ground will be applying its opposing pressure, even sometimes the capillary pressure if there is water. So there will be combined effect from here and here. That's why the reinforcement will be given at the center in grade slab, or even if you take the road constructions where we give double bars, they will be at the center rather than at bottom or top. Yeah, this is about the fluid mechanics summary. Yeah, proceed.
How far does the capillarity will rise in this tube, like as you have explained?
Yeah, the capillarity will be like in mm only, like 7 mm, 2 mm. It will be very less based on the
Yeah.
size of the tube. My answer is wrong. When you take the tree, how far it is going? If it is a palm tree, it is going much higher, right? The capillary rise.
Then the
Yes.
yeah, go ahead.
So the capillary rise, when go technically, the H is 4T cos theta by gamma W into D. So it depends on different parameters like surface tension and weight of the water and the diameter of that tube or natural pore. If the diameter of the pore is very, very small, then the capillary height will be very, very high. And if the water, instead of water, if there is mercury, there will not be capillary rise, there will be capillary down actually. The mercury level will come down there, so on. So, and it also depends on cos theta, that is angle of contact because of adhesion. Adhesion is nothing but attractive forces between two different materials, as one of the friend has mentioned that. So it depends on many parameters like 1, 2, 3, 4 parameters for the height of the capillary rise.
Thank you.
Yeah.
And do we have pitot tube too?
Yes, pitot tube is a pressure measuring device in a, that's a good question. We have pitot tube. We have pitot tube Do we have something like pitot static tube also? So we'll see what we use. Pitot tubes looks like this. If it is a tube running here with the fluid, we'll just make a hole and place a tube here, which we call it as pitot tube. Pitot tube we use it to measure the pressure energy over there. We'll see about that also. Yes, you are right.
Yeah, thank you.
Okay, I will ask my team, our friend Venki, to upload these notes well in advance today, so that you can have a look on the session and we'll come ahead. You can see here, this is a YouTube, and it is a barometer. You can see here, there are some calculations based on the pressure, so and so, and then, the pressure will be exerted by the fluid on the plate inserted in the fluids. There are plenty of formula for that. And then you can see the buoyancy as you guys have answered it. And there is flow of fluid inside this. There are different principles like continuity equation, so on. So we'll see that, and then we'll jump into, there are something like total energy line, hydraulic gradient line. We'll learn about them, some basics. And then we jump here, something like laminar flow, uniform flow, so on. So actually, these were not there for the syllabus. So no need to worry. And there is some, orifice meter and venturi meter. Orifice meter is again like we place a plate inside the tube with some orifice, that is a hole here, and we can have some measurements. And that's it. We'll learn about the, impulse momentum. That's it. That will be the end of the session, where I said the impulse is about the turbines, where it will heat it to create some kinetic, in a mechanical energy. Yes, that's it. End of the day, end of the subject there. And all the things which I have done here, they are extra. No need to study them. Yeah, thanks for the session. If you have any doubts, you can proceed. Otherwise, we can meet in tomorrow's class.